Husky Satellite Lab is sponsoring one of the capstones this year. It's a moon-related capstone. How is it moon-related? Well, it's called a moon thruster. What does a moon thruster do? Well, we're going to find out very soon, but it looks pretty darn cool. So first of all, a bit more about the sponsor of this project. The sponsor is the Husky Satellite Lab at the University of Washington. The Husky Satellite Lab is composed of a bunch of students. You might not know what we're doing, but we're sure passionate about space, and we build satellites that do go to space. So where's this project actually going to be applied? What clients are going to use it? The Husky Satellite Lab has some upcoming projects that are going to make use of this type of thruster. The most immediate one is HuskySat 2, which will be a technology demonstration of the stuff done in this capstone in preparation for HuskySat 3, a moon mission. Now, what are the requirements for this moon thruster that we're working on? Well, the primary objective is that it needs to prototype and ground test a cold gas thruster that can get HuskySat 3 from a near rectilinear halo orbit down to low moon orbit. One of the secondary objectives for this mission is to be compatible with the HuskySat 2 satellite, so that it'll be easy to integrate and demonstrate in space. Additionally, we want to document this project thoroughly, so that future teams have an easy time replicating our results and building off our work. So who's building this on this capstone project? First of all, we've got Mitsuki. He's our propulsion expert and knows everything that there is to know about rocket engines, to some extent. We also have Oliver, who knows everything there is to know about thermodynamics, and William, who knows everything there is to know about structures. Alnus is a physicist, and perhaps he sometimes does useful things, but we're not really sure. There's also Sarah. Sarah does propellant transfer analysis and battles with suppliers. On the right we have Brad, who does manufacturing, and not pictured is Stephanie, who does propellant storage analysis and design. The first part of our design process was conceptual design. We did high-level trade studies and analysis of various alternatives for the overall concept. Then we went into detailed design, so that meant a lot of CAD, and even more CAD to design everything. After that, we went into manufacturing. Making chips fly, it's so great to see things coming together physically. So, a lot of fun, but unfortunately it happened at the last minute a little bit, as well as integration. So when does it all come together? Well, unfortunately we had some big shipping delays, of the order of 4 weeks. So here's a cool screenshot of the CAD model that you can look at, and hopefully we'll have the propulsion system running soon. The main technological contribution that this project makes is that it makes space easier in terms of giving an open source base for rocketry research. It additionally makes an economical impact by making rocketry cheaper to access for university teams. Additionally, the environmental impact of this engine is some 10,000 times smaller than some alternative propellants. Finally, on the social impact, it's making space more available by making space research accessible to undergraduate students. Thank you everyone for watching, and we would love to thank our advisors and supporters.